the world I move in to say that I am not an architect. Um, I teach in the Department of City and Metropolitan Planning at the University of Utah, but I am also not a planner by training. I am an ecologist by training. So I have an undergraduate degree in geography and environmental studies. And then I got a PhD in landscape ecology at CU Boulder. And what I studied for my PhD was actually pollinators, was wild bees and how well they do in kind of fragmented suburban landscapes. And I ended up not by plan or intent, but to my great delight, teaching in an urban planning department. And I have ended up becoming the director of a center at the University of Utah called the Center for Ecological Planning and Design, which is a campus-wide, highly interdisciplinary center that focuses on the built environment, communities, and ecology. So bringing all of those different aspects together. So we have elements of social science, of natural science, of design, engineering, many of art. We have people on the steering committee representing all of these wildly different fields of endeavor. And so once I can figure out how to actually get my, there we go. So what I have become obsessed with in the last couple of years is actually carbon in the built environment. And I should say that this is not, even though I'm an ecologist and carbon is certainly one of the things that ecologists study, it is not my field of ecology. What I have studied in the past didn't really look at the chemistry of the environment. So looking at carbon is actually fairly new for me, and thinking about the built environment on this elemental level. And the reason I got into thinking about this in the last couple of years has been before 2020 happened and all the craziness, there were several articles and reports that came out in sort of sometime in 2019, I would say, where people were pointing out that we are not on track at the moment to meet the goals of the Paris Climate Accords. And that if we want to have any hope of meeting them, we need to really, really pick up the pace. And what that means, I think, in order for us to do it, what has become increasingly clear is not only do we need to reduce emissions, we're shooting too far ahead, too far past the goals for reducing emissions to just work, to work on its own. We need to get past emission reduction and into active drawdown, simultaneous active drawdown of carbon out of the atmosphere. And that is a shift in thinking, I think, for all of us. So we talk about reducing emissions, we talk about carbon neutral even. But what I started to think about was, where are the opportunities for us to go beyond carbon neutral? Where are the opportunities for us to actually go carbon negative? Because we're going to need to be going carbon negative somewhere in order for us to avoid a really runaway extreme climate change. So this question has largely been exploratory for me. And the reason I'm here today is that I feel that architects are critical people to help me explore it. And I hope that I can help you explore it too, because I think the answers to how to do this are not known yet. All we have are ideas. In many ways, all we have are questions. And it's all opportunities for any one of you, any one of us, any group of us to come up with partial answers, partial solutions. So really, I guess what I'm doing here is putting out some questions, some ideas. I'm trying to throw a lot of different seeds into fertile ground, and perhaps something will grow, who knows? All right, so my fundamental question here really is, how can we make cities more like forests? So let me move my screen so I can see what I'm talking about. All right, so today I'm going to talk a little bit about carbon in cities and then carbon more generally. So I always feel a little self-conscious showing these, like, undergraduate textbook diagrams of the carbon cycle, but it's something that I, as an ecologist, have had to go back and review and kind of get my head around what's really going on here. So I'm going to talk about the carbon cycle a little bit, which may feel like an undergraduate science class, but maybe that's fun. And then I'm going to come at the end to talking about some concepts and trends that I'm really interested in, that I see as kind of the interesting seeds. It is definitely not an exhaustive review of what is going on out there, but it is just sharing with you the things that I think about in my head. All right, so just to start from where we're at. So in this century, we know the global human population is still growing. That growth is slowing down. We're not sure where we'll stop yet, but we're going to keep adding probably at least a couple more billion people. And almost all of that population growth is anticipated to be in cities. So we are an increasingly urbanizing species. Currently, urban areas represent about 3/4 of the anthropogenic human-produced carbon dioxide emissions, which are about 85% of the total greenhouse gas emissions for the global budget. And then this pie chart down below is breaking up those into the different contributions of different parts of the urban areas. So we have industrial, a little less than 1/3, transportation at about 1/3, and then about 40% is coming from buildings, from the work that architects do. And so what I think is really important to think about here is all of that human population that we haven't added yet, all of that city that we haven't built yet. And just thinking about that opportunity, that potential for changing the way we build cities, for the way cities fundamentally function on this elemental level. So some of the ways into looking at carbon in cities is we can think about energy. So we can think about power demand for all of these different functions. We can think about transportation systems. So there's certainly a lot of movement right now to reduce carbon in transportation systems. We can be thinking about carbon in construction processes and construction materials. And then we can think about these processes, opportunities for retrofitting, and we can think about land use. So I'm not going to think about all of these things today, but thinking about cities in a very sort of whole system way, these are some of the places where we can be thinking about carbon and reducing our emissions of carbon. So my vision, what I want to get to, is from what we have on the left, which is cities are a major net contributor of carbon emissions to the atmosphere. What I want to ask is, how can we move cities to be net carbon removers from the atmosphere? So how can we get cities from putting carbon into the atmosphere to pulling carbon out of the atmosphere? I don't know if this is possible, but this is sort of my little mental exercise here. So that means we go from sort of the concrete truck, the cement truck here, which is symbolizing the emissive model, to a tree, which is symbolizing the more absorptive model for carbon for cities. So again, just some of the pieces that one could think about here, and I'm not going to today, but we can think about a technological approach. So there are a lot of people who are looking at different technological approaches, not just to reduce carbon emissions, but to potentially go carbon neutral and carbon negative. So there are different carbon capture technologies, replacement of fossil fuels, basically any fuel replacement though is still going to be burning something, and alternative building materials and processes, which I'll be talking about in a minute. You can think about it from an ecological perspective. So what are the role of urban parks and forests in this city in our urban carbon cycle? We can think about behavioral changes. So the carbon footprint of our lifestyles, of our housing, and of our choices. And then we can think about policy and economics and various different incentives that can make that shift. So these are all pieces of a transitional shift from net positive to net negative carbon emissions for cities. All right, so here's the fun part. I'm going to talk about the global carbon cycle. And it's important to note this doesn't really talk about the different timescales associated with different parts of the carbon cycle, but I think we all understand that these geological reservoirs down here are the result of millions and millions of years of geological time, geological processes. So if you don't consider the subsurface portion of the carbon cycle, you have basically this interaction between the biosphere, between the living stuff on the surface of the earth and the atmosphere and the ocean. So you have living green things. You have trees and plants that absorb carbon dioxide via photosynthesis, and they fix it into biomass. So their job is to pull carbon out of the air, and they hold it in the living materiality of plant matter. And then anything that eats those plants then also incorporates that carbon. So the carbon that makes up our bodies was originally, fixed by plants using energy from the sun. So we and all other living things are a carbon sink. So we are holding carbon, keeping it out of the atmosphere. Now, right now, our goal is just to keep carbon out of the atmosphere, right? So as long as living things are alive, they are holding carbon in their bodies. As long as formerly living things don't decompose, they continue to hold carbon in their bodies. So even the dead leaf litter that's lying on the ground outside my window right now is still holding carbon. It is still holding carbon out of the atmosphere as long as it doesn't decompose. So if you look at things like peat bogs, right, which are like meters deep, very dense organic matter that hasn't broken down, that hasn't decomposed. That's what permafrost is. So there's actually tremendous amounts of carbon that's stored in the world in non-decomposed plant matter or organic matter. The oceans are also full of carbon, so lots of living things. When those living things die, they sink to the bottom of the ocean, and generally they don't decompose all that much. So that eventually, with compression from the weight of the Earth's crust, eventually becomes fossil fuels. Again, coal is just compressed former or living matter. So then our current imbalance, our current climate change issue comes from the fact that all of this millions and millions of year old former living matter is now being pulled up back to where, when we burn it, it can be re-released into the atmosphere. So that's just a really, really long scale element of the carbon cycle. But it is resulting in an atmosphere that's a lot warmer than we are comfortable with. So humans evolved in a cooler period once all that carbon was long buried before humans ever came on the scene. So really our climate change fears have to do with the cities, the societies, the human existence that has evolved under a much cooler, less carbon-rich atmospheric regime on planet Earth. So ultimately, what it comes down to is we're emitting lots of extra carbon into the atmosphere, serves as a greenhouse gas, traps heat, traps energy, makes for all that trapped energy makes for much more extreme weather events, in addition to overall just greater heat, so higher temperatures. And then we have the same processes. There are not any more extreme processes or fast processes to pull that carbon back out of the atmosphere again. So we still have vegetation is basically it. Some carbon deposition, so carbon falling out of the air and landing on the land or in the water. But we don't have a strong, fast counterbalance to pull that atmospheric carbon dioxide back out that can balance our fossil fuel burning. So let me zoom in a little bit on basically this little vegetation part, okay? So we have the natural vegetation on the surface of the Earth. And then we see, I guess let me dig into this diagram a little bit more. So wherever there's green stuff growing, chances are that we probably have net negative in that area. And I'll come back to that. Where you have massive wildfires happening, not only is that destroying beautiful forests that we love, but it is releasing more carbon dioxide into the atmosphere. And wherever you have land use change, i.e. urbanization or other land uses that reduces vegetation cover or that removes forests, in general, you are going to have a net contribution of carbon to the atmosphere. So zooming in on this vegetation element of the carbon cycle, we have, if you are in a forest, you are seeing trees that are taking up carbon dioxide. Now, it should be noted that plants both photosynthesize and respire. So when it's not warm and sunny outside, plants use the sugars that they've created via photosynthesis, and they actually burn those to keep themselves alive for their own metabolism. So probably close to half the time, plants are actually releasing carbon dioxide, not pulling it out of the atmosphere. But in general, in a forest, there is the net balance is in favor of more carbon dioxide coming out of the atmosphere and being fixed into the biomass of this forest. So where you have, then the fate of that biomass becomes the question, right? So you have some that falls as leaves or needles to the forest floor. It may decompose It may sit there for a long time before it decomposes though. And as it decomposes, it becomes soil carbon, which is actually a fairly good storage pool of carbon. So forests are these amazing net carbon storage systems. They take carbon dioxide out of the air and they fix it into biomass. Now, when you have carbon export from forests, that carbon is then being removed from the forest in the form of wood or other organic products like fruit or nuts. And then your carbon equation becomes dependent on what happens to those forest products. So coming back to this idea of photosynthesis, net storage is the physical biomass of the tree. We want more of this because wood in particular is a long-lived biomass product. So the possible fates of the stored carbon of a tree are, if you leave the tree in the forest, it will stay there for the lifespan of the tree, however long that is. And then the tree will fall down when it dies, and it will decompose in situ. So it will decompose there in the forest, and that carbon will be cycled back into another tree, or some of it will be lost to the atmosphere. It could burn. There could be a wildfire, in which case that carbon goes back into the atmosphere. Or it could be harvested for wood products, in which case it's removed from the forest ecosystem. So let's look at this. So those wood products, if they are used for, say, paper, paper is a fairly short-lived wood product that's probably going to end up being burned or decomposed fairly soon. But if it's stored as wood in a building, then you're looking at decades, probably, in which that biomass, that carbon, is being taken out of the atmosphere and stored away so it doesn't break down. So this is, looking at it from a system sort of accounting level, this is great. Now, I'm going to come back to building with wood in a minute. Oop, not that soon though, because I have, as an ecologist, I have some concerns about the sustainability of constantly removing biomass from forests. So this is a diagram that I pulled out of some forestry textbook that describes this sustainable wood product cycle. Oh, good, we have a hand up. And I need to figure out how to, just go ahead, Jessica. I can't hear you. Did you have a question? It says that you raised your hand, but I can't hear anything.
If it's Jessica Sheridan,
Hi.
There you go.
I hear you now.
Sorry, that was a mistake.
Oh, okay. All right. Let me just move this. So the I am concerned about claims that we can, infinitely continue to harvest wood from forests. And I will come back to this. But it makes sense from a general accounting perspective. But forests are more than just trees, and they're more than just stored carbon. And so I don't want to rest too heavily on the sustainability of this sustainable forestry concept. I think it's probably fine at a small scale. I don't think it's going to solve our problems at a global scale. So we'll come back to this. All right, so that's my sort of discussion of the carbon cycle. Should I pause and see if anyone has comments or questions on carbon more generally?
I don't have any in the chat.
Okay, great, thanks. All right, so I'm gonna then come to some of these concepts. So the first concept kind of leads pretty naturally from the sustainable timber concept. So from what we know about the carbon cycle, it makes perfect sense now to let our forests, the world's forests, grow wood products for us. We harvest those products and we turn them into buildings where they're locked away for decades and they're keeping that carbon out of the atmosphere. And so one of the big trends we see now is timber construction, also known as mass timber or cross-laminated timber. I'm sure I'm talking to architects, so you guys, I'm sure, know what I'm talking about. And here, the big push that's coming in our part of the world is coming mostly from Washington State, where they have quite a lot of timber, by the way. And they have been really pushing the mass timber construction concept. And it's becoming more and more possible to build multi-story, to go beyond the traditional 3 or 4 story timber construction to, basically high-rise construction using mass timber. It is claimed, and again, I am not the person to assess these claims, but it's claimed that mass timber has similar structural properties to concrete. So we're not talking about 2x4 construction here. We're talking about, timber that's being bound together into these building materials. It is fire resistant because of the way it is processed and bound together. It is argued that it is easier and cleaner and less damaging construction. And it, from my perspective, it locks away carbon for the life of the building, which is awesome. And we're just starting to see some mass timber construction happening here in Utah, which I'm excited to see. I think it's, it's important to be trying this out and seeing how it does. And you can hear the concern in my voice, but I'm actually very much in favor of some mass timber construction. So this is a local source. Again, maybe you guys are probably already familiar with this, of Euclid Timber up in Heber, who have been harvesting beetle kill, of which, as you know, our Utah forests have a lot of beetle kill wood right now. And they are creating these interlocked wood systems that don't use adhesives or anything. Again, they're fairly small scale. This is not building with mass timber, but it's an example of the kind of thing that I think at a small scale makes a lot of sense ecologically. Now, getting to my concern with mass timber slide. My main concern is with sustainability as it scales up. So you read these magazine articles that are like, mass timber can save the climate crisis. And I'm pretty sure that there is no way that we can sustainably, with or without quotes, harvest enough timber in the world to solve the climate crisis. So particularly with additional threats to forests like wildfire. So the fires that we saw up and down the Pacific coast this summer were devastating, not just on a local scale, but on a global scale. Also the Australia wildfires. That's all carbon going up in smoke into the atmosphere that would have been better in a standing forest or being used for something like this. So those wildfires are profoundly tragic on so many levels. My other concern is habitat destruction. So a forest is more than a crop field. A forest is an entire ecosystem with lots of other species that depend on it, that make it their home. And so when we look at forests as cropping systems, as an ecologist, that concerns me deeply. I don't think we know a lot about the life cycle of mass timber products yet, because it just hasn't been around all that long. So that's an open question. And then there's the question of the adhesives that are used to bind the wood together and whether those emit volatiles into indoor air quality. It's just a question. And I think there are a lot of different answers to that question out there, depending on the product and depending on who you ask. So having expressed both enthusiasm and skepticism about timber building, I want to move beyond thinking about forests as our source, as our source of biomass, or as our carbon storage mechanism. I would love us to really work on actively growing our forests, but not necessarily thinking about them as harvest systems. I am interested in ways to produce carbon storing building materials within the city. And in doing so, we make our built environment itself literally regenerative. And so the next few slides and musings I have are really looking at opportunities for biomass production and use in the built environment. Okay, I'm gonna have to go fairly fast because I don't want to eat up all my time here. All right, so second concept or trend is looking for opportunities to incorporate carbon harvesting, literally via photosynthesis, into urban landscapes. So where can photosynthesis be happening in our urban environments, in our urban landscapes, where it will actually then be producing carbon storing long-term biomass? And the first thing that comes up whenever I start to think about this is bamboo. Bamboo is great because it grows super fast, and it grows very densely, as you can see from some of these pictures, and it produces an amazing building material. So I think about questions like, well, what if we dedicated, again, looking out my window, of the landscape space available in our city, what if we dedicated X% of that to growing something like bamboo or other building products? Or not necessarily this city, but other cities. So if we start to see some of our urban landscape as carbon storage / cropping landscape, what does that look like? How much does that get us? And again, that's sort of an open question, right? And then I think about Salt Lake City. So in almost every talk I give, it seems, for some reason I end up showing a picture of the Salt Lake Valley seen from above, which is always, it always kind of blows my mind, because every time I look down on Salt Lake City, I'm like, this is a forest. This valley is an urban forest, and we live under the canopy of this urban forest. And for the purposes of this talk today, this urban forest that exists in the Salt Lake Valley, we all know it wasn't there, right? It wasn't there before the pioneers came and settled it. Those trees were planted by settlers and watered by settlers. And as a result, there's probably, I don't know for sure, but there is probably a lot more carbon stored in the Salt Lake Valley than there was before Salt Lake City came to be here, which is kind of funny to think about, right? And that's because of watering. So we give supplemental water to our landscape in Salt Lake City to make it green and beautiful. And as a result, we are storing more carbon in our landscape now than would have been stored in this same valley 200 years ago. So something to think about. Can our urban forests serve to, they do store carbon. Now, I should add that there have been studies that show that the contribution of urban forests to carbon storage in the overall carbon budget is pretty minimal. But if you look at arid places like Utah, it is definitely a bump from what would have been there before. Again, because of that additional water supplementation, which is that a reasonable price to pay for that benefit? I'm inclined to think that it is, but it's something that we need to think about. But the other thing is that we do not use our urban trees as building materials. So when a tree gets taken down, it generally gets chipped. It's not, which contributes to decomposition, which is not, it is perhaps not the highest and most optimal use for all that wood that we're producing in the Salt Lake Valley. So concerns about urban forests and landscapes as our carbon storage building material source are, in this climate, water. So again, there's a water price to pay. I'm sure the first thing all of you thought about was space. So we have very limited space. The denser a city is, the less and less space you have to be growing stuff in the landscape. And then there are questions, and this really comes down to, I think, why we don't use our urban trees for much of anything when they come down, is harvesting. It's very difficult to efficiently and safely cut trees down in an urban environment. And it's generally not particularly cost effective to do it to produce a building material. But that doesn't mean it couldn't be done, just means somebody needs to figure it out. So going back, just one thought process here. So as an ecologist and a planner, I have tended to work in this realm, in the landscape realm. So most of the work that I do is looking at landscapes, not at buildings. And it's only when I sort of started moving into this carbon thinking and thinking about the fact that we need to go way a step further to become carbon negative. And that was where I basically came to the realization landscapes are not enough. We have to get into buildings if we're going to make a significant dent in our carbon. And so then we come to this third concept, which is if you just see the landscape as the only space for things to be growing and photosynthesizing and storing carbon, then you limit your thinking in the urban environment. So then you ask the question, how can photosynthesis, how can plants, how can organisms that are able to capture carbon be incorporated into buildings themselves? And that, I think, is probably why I'm here talking to this audience today. So this is the new terminal in the Singapore airport, which I want to go to Singapore just to go to the airport. And Singapore certainly has the reputation anyway of leading the world in terms of thinking about how to incorporate plants into the built environment without using land surface space. So they're definitely pushing the envelope on this question. So these are just things that I think about when I think about how do we incorporate living stuff into buildings. So this is an idea that's literally taking that, it's taking that concept literally, and it is growing buildings out of trees. It is growing a building. So it's providing a guiding structure and then planting trees, which will grow to fill out the shape of the structure, which I'm guessing that most of your reaction is the same as mine, which is that is beautiful and awesome and will take decades in order to actually grow a building. So it's not super practical. And I agree with that. So I'm putting it out there more as an answer to the question of how do you literally grow buildings that photosynthesize? All right, so that exists. Someone's doing it. Here's one that just uses a metal structure instead of a wooden structure to guide the tree growth. And then we have the slightly less radical, but perhaps slightly more practical concept of things like living buildings. So buildings that incorporate plants in some form into the interior of the building. So living buildings are not literally living buildings in the sense that they consist of living tree matter, but they do contain living systems within the building that perform a variety of building functions. So I'm going to tell you a little snippet about my childhood, actually. So this is not part of my professional life, but part of my childhood. So I grew up in a family that not my parents, but my aunt and uncle helped to found the New Alchemy Institute in Cape Cod in the late 60s and 70s. And part of what New Alchemy built were these buildings called bioshelters that were designed to basically be relatively closed system buildings. So there was food production that happened inside the building. There was water treatment and water cycling through the building. So I don't know, I would love to know, with an audience of 80 or so architects here, how many of you ever studied the Arc on Prince Edward Island in part of your architectural studies. But it has not caught on, obviously. There aren't a lot of bioshelters in existence today, but having grown up in my aunt and uncle's house, which is not pictured here, and also this is the house I did grow up in. And this addition on the back was designed by the same architects who designed the Arc on Prince Edward Island. And it had some of the shared features. So these systems really do incorporate some biomass. They're actively growing stuff. They also incorporate these fish tanks, these aquaculture tanks, which are another form of biomass. So again, it's a way to where having the living stuff isn't a waste of space in the house. It's actually incorporated into the function of the building. So this is just getting a little bit more into the anatomy of a bioshelter. So the water is that cycles through the building is treated on site through a wastewater treatment system, but also the water from the fish tanks is processed through a food production system as well, because the fish fertilize it. And it also has all the passive solar heating and cooling elements as well. So it's like this basically all of the systems that the house needs are incorporated into the building. It needs very little external input. So these ideas grew into the concept of eco-machines for on-site wastewater treatment, which was sort of a radical alternative concept for a long time, but have now kind of come more into their maturity. So this is a project, this is a full-on you guys probably know all about this too. This is a development in very central Portland, Oregon. It's got 4 multi-story high-rise mixed-use buildings, and the wastewater, both gray water and sewage from the entire development is treated in this eco-machine, passed through a series of wetlands that form the landscaping of the project. And so this is, again, a way to incorporate plants and living systems into the urban fabric, not just for the sake of carbon, but because they do all sorts of other valuable things for us as well. Then we have the concept of green roofs and green walls. So we maybe have more opportunities than we think about to invite photosynthetic friends to grow on other surfaces of the urban environment besides the ground. Now, my students always get excited about green roofs and green walls. And I always say, this is Utah. It's a really tough environment to go growing plants all over your roofs and your walls. So don't get too excited about it in Utah. But I do think that we need to be thinking about water and opportunities to use what water we have to support the greenery that we want. I might skip the energy implications, but I think it's important to note that again, this isn't just about carbon, that once you start incorporating, like for real, living systems into your building, there are some really neat water and energy implications that come along with that. And again, having spent a lot of time in my aunt and uncle's house, which had a massive greenhouse on the south side with these big, like 8-foot high fish tanks, it was a really lovely environment to be in the winter and in the summer, because those big tanks of water have amazing thermal regulating capacity. So the air in that house was always pleasantly moist, but not unpleasantly humid, except because Cape Cod summers are kind of unpleasantly humid. And it wasn't unpleasantly cold in the winter either. And it always smelled like plants. It was just a really, really delightful, well-regulated internal environment. Then this is a local example that I think about a lot. So this is the South Davis Wastewater Treatment Facility. And wastewater treatment, generally in Utah, the regulations require them to remove kind of all the solids and kill the things that might make us sick, but they do not require the removal of nitrogen and phosphorus, which are nutrients for ecosystems, but they tend to feed our harmful algal blooms when they actually are then released out into our lakes and streams. So at the South Davis Water Treatment Plant, they have installed an algal farm in which they take their wastewater effluent after it's gone through all the other treatments. So what's left in it is basically nitrogen and phosphorus. They pass it through these algae tubes that are exposed to the sun. The algae grow like crazy. The water comes out of the other end super pure, because algae are really good at growing fast and taking nutrients out of water. And then they harvest that algal biomass and sell it. So they're actually making money off of this. They sell it to make bioplastics. Now, which are used to make running shoes. And so my question is, what else could you make with those bioplastics? Because running shoes, again, they're locking some carbon away for a while, but I would like to know, can we lock it away for longer? Could we be making, I don't know, floor tiles or ceiling tiles or building blocks or something out of bioplastics that is storing that algal carbon away? Okay. Oh, I'm running out of time. Okay, so this last one, I don't have a lot to say about. I haven't studied it a lot, except that there are a lot of innovative materials that are emerging that can help to contribute to carbon capture in the built environment. One, fly ash concrete has been around for a long time. I consider fly ash concrete sort of a less bad option. It's not necessarily locking away much carbon, but it is taking a waste product and using that as a building material rather than the tremendously fossil fuel intensive production of regular concrete. And then there are these there's just as an example, there are these materials made of fungal mycelia, where you actually grow these bricks, or you can turn them into boards, you can make insulation. There are all of these materials out there now that are basically made of fungi, fungal biomass, that are supposed to have lots of really great structural properties, and also that they are resistant to termites and things like that. So there's a lot of innovation, I think, happening in building materials. I would like to see there being even more innovation in building materials, and that this ventures beyond ecology into realms that aren't my field. But I do come back to this idea of how can we be using something like this solar farm or spaces, how can we integrate these spaces within our built environment where we're using, for example, waste products from our urban processes to grow biomass that stores carbon, and then we turn it into the building materials and we lock that away for the life of the building somewhere. Ultimately, that's the concept I'm interested in getting to here. So then this is just kind of summarizing what I said in a series of questions. But I think the reason I'm here has to do with this last question. So who do we need to work with to find these solutions? Because no one individual, I think, amongst any of us is going to figure this out. It takes engineers, materials scientists, architects, designers, ecologists, all these people working together to try to find any one of these solutions. And that, I think, is the interesting challenge. So with that, I will stop talking, and I would love to have a conversation. If you guys have questions, whatever.
Well, thank you, Sarah.
My pleasure.
First, I'd like to offer you a hearty thank you. Appreciate it. This end of year continuing education, I know, is very valuable to a lot of people. I don't know if you already got to this. I did see a question in the chat about.
I didn't. I'm not. Hold on. I'm not seeing chat right now.
I did.
Oh, you're right. There's a bunch of stuff in chat.
Yeah, a question about how much of the stored carbon in organic materials comes from the air versus. I'm not sure if you answered that already.
I think it varies according to the system that you're looking at. But I think it varies. But certainly in a forest where there's a lot of stored carbon, that would be coming from the air primarily. A lot of it would come from the air.
I don't see a lot more questions.
Okay.
I will leave it for just a couple minutes here as we wrap up. I again want to say thank you, Sarah, for joining us and giving us. I am an earth by background, and I always find these topics interesting. I love the intersection of the built environment, the natural environment, and what we can do to be good stewards, which I appreciate. So I will also say, if you would like to contact Sarah, she's got her contact information here, sarah.henners@utah.edu. Of course, you can always contact Sarah or I here in the AIA Utah office, and we'll connect you as well.
And if you guys have brilliant ideas, or not, like if you're just like, I don't know if this is a good idea, but I had this thought or idea, I would love to hear them, because basically I put out there what I've got right now. And if any of you have ideas or opportunities to play around with any of this, I would love to know about it.
Oh, one last question here. It looks like, do you know about additional carbon capture and utilization methods being reviewed, like designer fuel?
Yeah. So last year I initiated this group on campus that I've largely let die now because COVID. where I just kind of put the word out on campus, who is doing anything to do with carbon capture? And mostly the people who appeared were engineers. And there are engineers on campus who are working on things like, deep geologic storage. So that's a thing. And a lot of people say we're not going to be able to do it if we don't engage in some deep geologic storage. But also people who have like machines that run air through the machine and they are able to capture carbon out of that air. Now, what they all say is then we have this product that at the moment has no market value. And so this carbon capture technology is not going to work until you find something that you can do with the carbon that it's capturing. But yeah, there's a bunch of people working on that as well. But again, it doesn't, like I said, it doesn't work in a vacuum because there's got to be a market for the material that they're producing. And that's why I love the idea of like algae bricks or something, because bioplastics are already a thing, right? It already exists. And we just need to repurpose it into buildings.
It's a very cool idea, very interesting technology. I do
Yeah.
see two other questions that were in the question and answer from one of our members here. Do you see carbon neutral building and planning concepts and practices being incorporated into local building codes anytime soon?
Local building codes. I don't know if anyone else sees that on the horizon. I'd love to hear it, but I don't think building codes are. So building codes aren't so much where I work. I work sort of more in the zoning codes world, which I can tell you is slow. So to change zoning codes is like a major deal for most cities. And so yeah, I don't.
As a former planning commissioner, I will say that's a place though where we can probably have quicker impact than the state legislature. Kind of to follow up on your answer there, Garrett, our state is unique-ish in that our building codes are controlled by the state legislature, and we could promote a bill that would do what you're suggesting. As an organization, we could lobby for such a thing. But normally what we get are the energy code updates that we've seen cycle through, and we could probably have a more impactful conversation there as well with a groundswell from our membership to help with that outreach to our legislators. So that's probably where the rubber meets the road on that, is going to be in the Utah State Legislature.
And I think when we see these, I mean, most of the advances on, what's being required of buildings tend to be still well within the slightly less bad category, right? Which is, and it's just it's dragging our feet so slowly. And yes, I'm in favor of being less bad, but if we could push something that's actually better than less bad, something towards actively good, that I think could move everything ahead so much faster. If we all had the opportunity to build living buildings, right? To incorporate eco machines into buildings. And that's been really hard in Utah.
Another question. Yeah, it is really hard. There's the political appetite that has yet to be found. A question too, is the goal with carbon really about doing what we can to make sure it exists somewhere other than the air?
Sure.
Yeah, I don't know if this influences your answer, but I always like to tell my kids, and I used to say in all of my urban planning introductions, the earth is a closed system. So
Yeah.
we've only got what we've got, and we're not making any more, and we're only recycling what we have. So it's not that we're producing necessarily any more carbon than what already exists. It's recapturing it, and yes, putting it in places other than the air.
Yeah, exactly. So, I mean, if I sat and thought about it, I could probably come up with maybe some bad examples, like places it's bad to store carbon that's not the atmosphere. But I think generally speaking, it's a really good initial question to ask,
Mhm.
right? Like, where can we put carbon other than in the air? And then the next question is there some harm involved in putting carbon in this place other than in the air? But
Right.
I think that's a really good first question. And again, if you have, the more you can do it so that it happens organically, literally organically, rather than us having to do a bunch of extra work to make it happen, even better. Like a tree grows without us having to do anything, right? That's just passive carbon storage. It's great.
And I'll have to make this the last question. Have you
Just
considered,
getting going now.
I know, have you considered how reusing the stock of existing building increases the overall urban carbon, quote unquote, storage? How much of an impact does an existing building have?
Right. Well, so I'm sure every single one of you has repeated the saying many times that the most green building is the building that's already built, right? So absolutely. I think if we can reuse the stock of existing buildings, that's doing no harm, right? Now, if we can reuse that stock of existing buildings by, say, renovating using mass timber, for example, or incorporating an algal farm into that retrofitted building, then you're starting to move towards, really having a cool impact. So I am absolutely in favor of retrofitting existing buildings, unless they're just horrible buildings. Like some of them I just can't even,
Yeah.
there are some that maybe just shouldn't. But,
Yeah.
but if nothing else, it's a structure, it's a physical structure on which you can be hanging or growing or doing something with.
I think the concept of embodied energy is absolutely part of our Beck code understanding and philosophy. And we certainly could, again, have legislative opportunities to promote bills that we don't have a rehabilitation code in Utah. We could create and promote one, but the legislature is not going to do it on its own. And
Yeah. Well, there need to be incentives, right? So there needs to be something that gives more value than embodied carbon to that existing building to retrofit it rather than to tear it down and rebuild it. And the system just isn't set up for that right now. It's so much extra work to retrofit an old building than to just knock it down and clear it away and build a new one. And that's problematic. That's problematic in an urgent kind of way. And and that gets into construction processes, which I didn't even talk about, but.
I appreciate you going as far as you did today. So we appreciate you. We would love to have you back at some point. I appreciate that.
I love this. I love hanging out with the architects. It's the best.
We're not a bad crowd. Appreciate it. Thank you for being here. If anyone, again, wants to contact Sarah, copy her email down here or contact Sierra or I here in the office. And with that, I'll just say I hope everyone has a very happy and very safe new year. And I hope to see all of you again soon.
Thanks, everybody. Thanks for coming.
Thank you. Have a great day, everyone.